purpose of this video is to show the behaviors of the two amplifiers that are internal in the HackRF. There's a what they call an IF gain amplifier. That's the one that this symbol is indicating. And then there's one that's called RF gain, which is right at the output of the HackRF. It's currently not on. And what I've got is the output of the HackRF feeding into channel 1 of the scope. It's currently running at 20 megahertz output, and the IF amplifier is at 27 dB. That's the application for that amplifier. I have a GNU Radio Companion script. Let me show you that. And the way that this works is it's just producing a sine wave output, and there are some GUI controls to control the frequency, the RF gain, and the IF gain. In the HackRF block, the Osmocom block, which is controlling the HackRF, there are these settings down here for RF gain and for IF gain. And those are the settings that are controlling the power output in the transmit mode. RF gain being the final stage before it hits the antenna, and then IF gain being the low noise amplifier that's before that stage of the HackRF. So IF down here, RF is up here. Okay, so when this thing runs, I have a GUI control. Let me bring that up. That allows me to move some sliders around and control the amplification, and you will see how that behaves. So I'll put this back over here, and let me move these controls into view of the camera. So the interesting thing is that the RF gain amplifier, which is over here, even though you have the ability to change the level of it numerically, is actually just an on-off switch. So what I'm going to do is I'm going to begin to move this up, and you'll see there's no change in the scope's level of the signal. And what happens is that the RF gain amplifier is turned on when the level reaches 14. So I'm just going to go up one notch more, and there it is. So now your gain is on. It's actually like a 14 dB gain, and the HackRF is actually now displaying that on the screen. I've measured some of that actual gain, and it's actually a bit more than 14, at least at this frequency. I'm seeing a gain of more like 18 from that RF amplifier. And now if I continue to increase the value of RF gain, you'll notice that nothing happens both on the display here, indicating the amplification of that RF gain amp, and nothing happens on the scope. So it's basically the behavior of the RF amplifier is just it's either on or off, and you can't control the level. So now I'm going to turn that off again, and I'll modify the IF gain. I'll just take it down first, and you can see that it's incrementally reducing the level of the sinusoidal output 1 dB at a time as I change this control. I can go all the way up to 47, which is a 47 dB gain, and you can see you still have a nicely shaped sine wave. This is 20 megahertz. We have a VRMS of 170 millivolts, about 500 millivolts peak to peak out of the HackRF with only the IF gain turned on. If I was to also turn on the RF gain, and actually with IF gain on and at its maximum, and I roll this up to 14, it'll turn on, and you'll see that the combination of the two of them results in a rather unpleasant looking sine wave. And so you'll see that this increase here in the RF gain has no effect. So there is some combination of RF gain and IF gain that lead to a smoother sine wave shape, or a purer sine wave, if you will. And it seems like if you leave the RF gain off completely, that you get a reasonable shaped sine wave. We'll look at that on the FFT. And there's the FFT of the sine wave, 20 megahertz, with IF gain at 47 and RF gain completely off. And yeah, here's the principal frequency, 20 megahertz, first harmonic, second harmonic, third harmonic, and so on. It looks reasonable, I suppose, with the gain level of 47. If we bring up the RF gain, you see we amplify the whole thing. We do get some more harmonics in between these principal harmonics. So that's the interesting thing that I basically learned today, was that RF gain setting is really just an on-off switch. It doesn't turn on until you get to an RF gain level numerically of 14 in the Osmocom sync control. And then the IF gain is controllable incrementally, 1 dB at a time. All right, that's it. Thanks for watching.